Here's figure 4.18, and what this is showing is just the density in terms of that bulk density number that we are learning about. The density in megagrams per cubic meter, which again is just a density factor, a weight divided by the volume of the thing factor. Okay, and what we can see is there's some things that we know of and we think of as dense. So here's concrete. Okay, concrete with a bulk density of 2.4, a little greater than 2.4. Here we have the particle density of a quartz mineral. So an actual mineral, we say 2.65. Recall that that is the density that we said we can assume that is the particle density or the mineral and rock density of soils. Okay. On the other side, we have something like peat. Hopefully you've dealt with peat moss or potting soil even is a close approximation of that. And for that, we've got a really, really low bulk density, 0.2 grams per cubic centimeter, 0.2 megagrams per cubic meter. So really, really lightweight soil, airy, fluffy. You can think of all these sorts of words. What we find is that that typically, okay, so up here, there's some of our soil textures that we know. Up here, there's some clay loams here as well, cultivated sands and sandy loams in this range. And you'll notice that the sandier a soil is, the higher the bulk density we have. Now that might be kind of counterintuitive because when you think of a sand, you think of the large pores in sand. And when we're thinking about the density of something, you think about is there a lot of space or is there a little bit of space? And so it's kind of counterintuitive. It says sand here has a higher bulk density, which means it's more dense per volume than something like a clay or a silt loam. And the reason for that, as you'll discover in your text, so we're in figure 4.18. That's on page 115 of your text. You need to read real careful the effect of soil texture on bulk density, and you'll see that with things like clay and silt loams, what happens is even though it's intuitively we kind of think that clay is thicker. What's really happening is there's a bunch of little bitty pore spaces, both small pore spaces around the particles, and even when particles are aggregated together in very small amounts. Even within those little bitty particles, or little bitty aggregates, there are even more small pore spaces. Okay, so let's bring in So what you see here is an example of that. So here's our coarse sand grains, okay, on the right-hand side. And you can see for the exact same amount, or the exact same, let's say, volume of particles. So we've got one of these particles that's completely solid here as a sand particle. And we have one that's close to the same size here. And what you'll notice about this one is that it's got all these little bitty pore spaces inside of it. So it's a very porous material, whereas this sand is not as porous. Okay, so let me take, well, I can't take that off right now, but so you can see the nature of the differences here. So we can say that something like a clay has more pore space. Okay, more pore space means it's less dense than sands, typically speaking, generally speaking. And this is the secret, this is why, is because we've got those little bitty micropores or intraped pores inside those little peds, inside this aggregate, that are also part of the pore space. Whereas in sands we don't. It's a completely solid particle. We have typically larger pore spaces, but we have larger pore spaces here as well. Plus, we have these little bitty pore spaces inside. So clays will tend to be lower in bulk density than sands are.